You're having a picnic when all of a sudden dark clouds start rolling in and the wind picks up. You hear a clap of thunder and then it starts raining. This is a common summer storm. But have you ever wondered how rain and thunder are made? Let's start with the rain. When you look up at the sky on a rainy day, it may seem like the raindrops just fall straight down from the clouds. But there's more to rain than meets the eye. If you want to understand how rain happens, you need to know about water vapor, clouds, and what's called the dew point. On a hot summer day, lots of water evaporates off lakes, rivers, and oceans, rising up into the atmosphere as invisible water vapor. As the vapor rises, it cools down and condenses around tiny particles floating in the air, forming clouds. The higher the clouds are, the colder they are, which means that the water droplets in them are very small. If you were to reach up and touch those droplets, they would feel cold. And since they're so cold, they don't fall as rain yet. For the water droplets to grow big enough to fall as rain, they need to be warm, and to get warm, they need to sink back down closer to the Earth's surface. As the water droplet sinks, it passes through a layer of warm air called the boundary layer. If the droplet can make it through the boundary layer without evaporating, it's big enough to fall as rain. So essentially, rain is simply water that has condensed in the sky and gotten big enough to fall to the ground. But while the rain is falling, you might also see lightning flashing and hear thunder rumbling. That's because when the raindrops fall, they collide with other raindrops and with particles in the air, like dust and smoke. These collisions create an electrical charge in the air. Positive charges gather at the top of the cloud and negative charges gather at the bottom. When the difference in electrical charge between the top and the bottom of the cloud gets too great, the air between them acts like an electrical insulator and zaps the charges together in a bolt of lightning. The rapid discharge of electricity through the air heats the air around it to 30,000 degrees Celsius or 54,000 degrees Fahrenheit. That superheated air expands rapidly, and the explosion of energy creates a sound wave that we hear as thunder. So making rain and thunder requires warm water, invisible water vapor, and a whole lot of energy. Now let's learn about some amazing places where all these ingredients come together. The Amazon rainforest is one of the most storied places on Earth, home to incredible biodiversity and some of the most bizarre creatures known to man. In the Amazon, the heat and humidity are so intense that even before the sun comes up, the air is saturated with water vapor. As the day progresses and the sun heats the rainforest even more, the trees release even more water vapor. All this moisture forms clouds over the rainforest, which scientists call a thermally driven rainforest. One feature of a thermally driven rainforest is that it has tall, well-developed clouds. Another is that it rains throughout the year. However, not all tropical rainforests are thermally driven. For example, in the tropical rainforest on the island of Madagascar, most of the rain comes during a wet season that lasts from November to April. The rest of the year, from May to October, it's dry. Scientists think that instead of heat, wind plays a bigger role in generating rain on the island. In fact, the reason there is such a stark difference between the climates of Madagascar and the Amazon is because of large-scale weather patterns called monsoons. During a monsoon, winds blow from one area of the globe to another, carrying huge amounts of water vapor with them. For example, during the dry season in Madagascar, the northeast trade winds blow across the Indian Ocean from Africa, bringing dry air with them. The dry air sucks up whatever moisture is left on the island and blows it toward Australia. Meanwhile, during the wet season, the Australian summer heat builds up so much that by December and January, it starts creating its own monsoon. Air rises rapidly from the continent's interior, forming deep clouds that produce torrential rain. This rain doesn't stay over Australia, though. It's blown out over the Indian Ocean and onto the shores of India and Southeast Asia, producing one of the wettest climates on Earth. When we think of rain, we usually picture water falling from the sky. But in some parts of the world, rain takes on other forms. Take the island of Samoa, for example. In the Samoan Islands, there is so much moisture in the air that sometimes the water vapor condenses directly into solid particles of ice. Instead of forming clouds, the ice crystals just float in the air, giving the sky a hazy look. And when they get heavy enough, they fall to the ground as a type of precipitation called hail. Hail is actually made of layers of ice like an onion. Each layer forms during a particularly intense thunderstorm, and when the thunderstorm is over, the ice falls to the ground. Sometimes hailstones can be huge, but they rarely survive the fall. That's why it's so rare to get a picture of hailstones falling from the sky. So far, we've talked about rain and thunder, hail, snow, sleet and freezing rain. There's also an obscure form of precipitation that you might not even have heard of before: supercells. A supercell is a giant hailstone that starts out as a regular hailstorm, but then the winds in the storm start swirling. That swirling motion causes the hailstones to grow much bigger. The biggest ones can be more than 20 centimeters in diameter and weigh more than 450 kilograms. No wonder only about 1,000 supercells have ever been recorded. Rain, snow, sleet, and hail all begin in clouds. But what are clouds made of? Clouds are made of millions and millions of tiny water droplets or ice crystals suspended in the atmosphere. How do these particles stay suspended and not fall to the ground? It is because the air in the clouds is moving in the same direction as the droplets and crystals. But if a droplet or crystal collides with a particle of dust or another droplet or crystal, it could gain a random amount of energy and change direction. If it changes to a downward trajectory, the particle falls and eventually hits the ground, which is why clouds eventually disappear. But clouds aren't the only things that can precipitate. Even dust storms can produce their own kind of precipitation. In a dust storm, strong winds pick up and carry dust and sand particles off the ground. Eventually, the particles become so heavy that they fall back to the ground in a wall of dust that can be more than 10 meters tall. While dust storms might not dump a lot of water, they can cause serious damage. In 2005, a dust storm in the United States was estimated to have caused nearly $1 billion in damages. Precipitation doesn't just fall on land, it falls on the ocean, too. In fact, most of the planet's precipitation falls on the ocean. But the way precipitation interacts with the ocean is complex. Sometimes precipitation warms the ocean, and other times it cools it, and this interaction affects currents and weather patterns all over the world. When rain falls on the ocean, it adds fresh, cold water to the surface, which can actually warm the ocean if the rain is warm enough. This process is called downwelling. Downwelling can bring up nutrients from deeper in the ocean, stimulating the growth of phytoplankton, which are microscopic plants that live in the ocean. Phytoplankton absorb carbon dioxide and release oxygen into the atmosphere. They also serve as the base of the ocean food chain, so when downwelling brings up phytoplankton, it kickstarts a whole process of biological activity that removes carbon dioxide from the atmosphere. However, downwelling isn't always happening. When cold water from the poles is sinking down into the ocean, warm surface water can move away from the coast and downwelling doesn't occur. This lack of downwelling leads to upwelling, where deep, cold water rises up to the surface. Cold water holds less dissolved oxygen than warm water. So, when cold water wells up from the depths, it can decrease the amount of oxygen available for marine life. Less oxygen means slower phytoplankton growth, which means less carbon dioxide is removed from the atmosphere. There is so much going on beneath the surface of our planet that we can't always see it with our own eyes. But every now and then, we get a glimpse of the dynamic processes that shape our world. Rain and thunder are one of nature's most awe-inspiring spectacles. From the smallest raindrop to the largest hailstorm, water is constantly cycling through our atmosphere, shaping our world in ways big and small. So next time you look up at the sky on a rainy day, take a moment to appreciate the incredible forces of nature that are at work all around you.